So we're going to finish this section out by doing Epsilon-Delta Proofs. So epsilon looks like a backwards 3, and delta looks like an 8 that wasn't quite finished out. Okay, these are Greek lowercase letters. Epsilon starts with an E, delta starts with a D, and they're in alphabetical order. So delta references X values or your distance from X. And then epsilon references your distance from your Y values. Okay, and this is just the formal definition of a limit, because you're creeping at it from either side, but it gets a little bit analytical, so I gave you some hints. First of all, you're going to take the limit if it already hasn't been given. Okay, whatever your epsilon is, you need to add and subtract it to that limit. Okay, and so I'm going to walk you through these in a second. Then take your expression or your equation, whatever it is, set it equal to both of the answers that you got in step 2 and solve for X. Okay. Once you do that, take those two X values you just found, and you're going to subtract them from your initial X value that you took the limit of. And that's going to tell you how far away from X you are. Okay. So I'm going to show you, on the first one, hang on, I've lost control. Okay, we're going to do this one. Mainly because I don't like this problem because there's no work to be done. But I want you to see what it is. So first of all, your expression is X plus 1. Okay, that's your expression. You need to find the largest delta. And then this is the analytical side of it, okay? The largest delta so that 0 is less than or equal to your X minus 2, which is less than or equal to your delta. That's a fancy way of saying how close to 2 are you. Okay, how close to 2 are you? And it's in absolute values because distance is always positive. Then your function minus 3, absolute values, because you're doing distance, is less than 0.4. So let me just interpret this for you. This stuff is going to reference your X's, okay? This stuff, where's my purple pen, is going to reference your Y's, which means this has deltas and this has epsilons, okay? It flat out told you what your epsilon is because it's a little tiny number of 4/10. Okay, so technically, from start to finish, I would say the limit as X approaches 2, okay? And I got the 2 from right here. So the limit as X approaches 2 of, what's your expression? It's X plus 1. Okay, and then they told you your epsilon is 4/10. Your epsilon will always be one thing, and that's what you're going to add and subtract. So here's the deal. Do you agree that X plus 1, or f of X equals X plus 1, is a linear equation with a slope of 1 that hits the y-axis at 1? So that's what this is. That's the dark black line. Okay, where did I get the 2 from? If you'll notice, 2 is in the middle of these 3 lines. So 2 is your target. Okay, so the limit as X approaches 2. 2 is your target. So I've now found that 2 different ways. I found it up here, and I found it down here. Okay, now what happens if you use direct substitution? Shove in a 2. What is 2 plus 1? It is 3. So where can I get 3 from? I use direct substitution here. I can also see it up here. Okay, and I can also see it over here. Because again, you've got 3 lines and 3 is the middle. Okay, so hopefully that makes sense so far. So now your epsilon is 0.4. So step 1 is take your limit. Step 2 is to add and subtract your epsilon to the limit. So if my limit was 3, okay, I'm going to add and subtract 0.4 to that. So 3 plus or minus 0.4. So 3 plus 0.4 is 3.4. 3 minus 0.4 is 2.6. So you'll notice those are the 2 values that are already here. Okay, they already gave you the 3.4 and they already gave you the 2.6. So now what's your next step? You just found these 2 values, so take your expression and set them equal to those 2 values. Okay, so again, my expression is up here, X plus 1. And now solve. So I have subtract 1, I get X is 2.4, or subtract 1, I get X is 1.6. Now notice again, if you look down here, there's your 1.6, and there's your 2.4. Okay, so they've already done this entire problem for you. I'm just kind of sort of breaking it down for you. So now the last step, people tend to want to stop here. You need to tell me how close to your target you are. Well, what was your target? Your target is 2. Okay? How close is 2.4 to 2? So subtract that. 2.4 minus 2 is 0.4. Okay? How close is this one to 2? So 1.6 minus 2 is negative 0.4, but it's a distance, so we make it positive. So it is also 0.4. If there's a discrepancy between these two, you always grab the smaller, but there's not. And so your delta is going to be 0.4. So what is this saying? You need to be within 4/10 of your x value of 2 in order to land within 4/10 of your y value of 3. So you're just telling me how close to x you need to be. That's it. You're just telling me how close to x you need to be. But again, if they don't match, okay, you're always going to choose the smaller value for delta. Mine matched on this one. All right, so let's do another one. Make sure I'm not skipping anything relevant. All right, so let's do this one. We have, it says the graph of the following function is shown in the figure. So what do I know? I know I've got, I'm not gonna do all the stuff behind it because they've already given you the values. So notice that your y target is 1. So if I take the limit as x approaches 2, okay, what is 1 over 2 minus 1? It's 1. Okay, so they've already given you that. So how close on either side did you get? You got within 1/100th. So notice up here. What is your epsilon? Your epsilon is within 1/100th. So now what's your delta? Well, you just need to tell me how close on either side. They've done the math for you. How close to 2 is 201 over 101? So I can tell you right now, put a big fat star on this one. You need to give this one in fraction answers. I don't know why it's spazzy, but it is. All right. So on this one, 201 over 101 minus 2. What am I doing? Okay. 201 over 101 minus 2, math, fraction, is 1/101st. Okay, it's a negative answer because of the way I put it in, but distance is always positive. So one of my deltas is 1 over 101. Okay, what's my other delta? So how close is 1/99th over 99 to 2? So 199 divided by 99 minus 2 is going to be math, enter, enter, and you get 1/99th. So your delta is not the same this time. So which one do you need? Always choose the smaller. So which one is smaller? 1 out of 101 is smaller than 1 out of 99. So that's going to be your delta. Now here's why you choose the smaller, because if you're reading the instructions, it says find the largest delta. The largest is the smallest. Why? Because if I grab the bigger one and say, hey, add and subtract that to 2, it's going to take me outside of the interval that I'm okay with for my y values. It's going to be too big and it's going to pop me outside of that window that I'm okay with. So if they differ, always choose the smaller one. Always, 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 because the smaller one is the larger one. All right, so here we go. This one, they're kind of sort of peeling it away at this point. So here's what I know. I'm going to take the limit as x approaches 1. I can get that from the picture, or I can get that up here because it says x minus 1, so that's your target. So the limit as x approaches 1 of 2 minus 1 over x. If you use direct substitution, you're going to get an answer of 1 because 2 minus 1 over 1 is 2 minus 1, which is 1. So look on this side. There's your 1 right here. How much did they add and subtract? They added and subtracted 1/10. So if you look at that, that's where this is coming in. Okay, so I just found out that I'm okay with getting 1 plus 1/10, which is 1.1, or I'm okay with getting 1 minus 1/10, which is 0.9. So now I actually have to do some math with it. So what I'm going to do now is take my function, which is 2 minus 1 over x, 2 minus 1 over x, and I'm going to solve for x. What x values are okay to use with this? So I'm going to subtract 2. So I get a negative 1 over x is going to be a negative 0.9. And then I'm going to flip-flop stuff. Okay, so remember that this is over 1. I can cross multiply and solve. So that is going to give me, if I have a negative 1 times 1, I'll get a negative 1. Or just recognize these are both negative, so they're going to go positive. Okay, So multiply this way, I get 1. Multiply this way, I get 0.9x. Divide both sides by 0.9. And what do I get? So 1 divided by 0.9 is, fraction, is 10/9, which I should have known that, sorry. All right, so 10/9 is an x value that's okay to use. So now do this one. Subtract 2. So I get negative 1.1. And then do your flip-flop, so I get x equals 1 over 1.1, and if you'll notice, 1 divided by 1.1 is going to be 10/11ths, okay? So I have 10/11ths equals x. Now, don't stop here. How close to your x target of 1 are you? Well, 10/9 is 1/9 away. So one of my deltas is going to be 1/9. How far away is 10/11ths? It's 1/11th away. So that's your other delta. So all I'm doing is taking these two things and subtracting them off of 1. So which one of these is smaller? They're not the same. So which one is smaller? 1/11th is smaller, so that's your delta. Excuse me. All right, let's do another one. So this one, I'm going to set the first one up for you, and you're going to do the second one. So I have the limit as x approaches 1 of 3x plus 1. What is your limit? Can you use direct substitution? Yes, you can. So take your 1 and shove it in. So 3 times 1 is 3, plus 1 is 4. Okay, so your y value is 4. Find the largest delta such that blah, 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 blah. That's your epsilon. So I notice that f of x references y's. Your limit references y's. So this must be my epsilon, which references y's. So I'm going to take my my 0.01, and I'm going to add and subtract it to 4. Okay, so 4 plus 0.01 is 401. 4 minus 0.01 is 399. Okay, so now what is my delta? And so I need to do this to 5 decimal places. And so what I need to start incorporating x's now. So first of all, grab your function, which is 3x plus 1. So 3x plus 1 equals this y value, or 3x plus 1 equals that y value. So I'm going to subtract 1. So 3x equals 3.01. Divide both sides by 3. So 3.01 divided by 3 is, it tells me to use decimals for my answer, so I'm going to use decimals. So I get 1.00, and I got a whole bunch of 3's. So 3, 3, 3, 3, 3, whatever repeating. Okay, so this one, if I were to graph it, would be a little bit to the right of my target of 1. So do this one. I'm going to subtract 1. So 3x equals 2.99. Divide both sides by 3. So I get 0.9966667. So 9966666, whatever. So that's going to be a little bit to the left of my target of 1. So how close to 1 is this? This one is 0.00333. I need 5 decimal places. So that is that far away. So now I need this one. Okay, so what is my, I get 0.00333, and so on. So these are, this is how far this one is from my target x. This is how far this one is from my target x, and this time they match. So I don't have to make a choice. So it's just 0.00333. So now just set it up again, but you want to be within 5 1,000ths of that. And that's all I have time for on this video, so we're going to finish it up with some word problems on the last one.